Let's look into greatest integer function. The name is thoda misleading. It's actually better called as floor function. So the mathematical expression is something like this. It will map real numbers to, what is this? Yes, integers. It's generally represented in this way in your books. Also, this way it makes sense actually. Let me kind of write it over here itself. You won't see this in your books, but yeah, this is how you also can represent the floor function as. So what it does is it assumes the value of the greatest integer that is less than or equal to x, right? So that behavior is kind of tough to talk about it over here. I'll show it off. Okay, let me run this. Yeah. So if I give an input of 2.2, right, I'll get an output of 2. If I give an input of 2.5, can you guess what is the output? 2 again. If I give an input of 2.6, output is 2 again. If I give an input of 2.99999, my output is 2 again. If I give an input of 3.1, the output is 3. Okay, if I give an input of 3, the output is 3 again. Okay, so if I give an input of 3.99999, the output is 3. Sorry, are you able to get what is happening? It will approximate to the lowest integer. Okay, you can think in that way. That's why it's called as floor function. That's why I call it as floor function, and I prefer to call it as floor function. But yeah, officially both the names are there, but I prefer to call it with this name. If I give an input of 4.2, the output is 4, right guys? So if I give an input of 0, what is the output? 0 itself. 0.9999, 0. What about minus 2.3? You have to push it down. Remember, push it down. It's minus 3. Okay, understood? You have to push it down because minus 3 is less than minus 2. Minus 4.5, it would be, yes, minus 5. Okay guys, so basically your domain and range would be something like this. So domain is any given input from real number, but the range is always an integer, positive, negative, if not 0. Okay guys, that's the behavior, and this is known as floor function, also known as greatest integer function.